Welcome 7th grade. You've been working so hard on volume and surface area of prisms. This will be a little bit of a break. Now, simplest form. Hopefully you remember how to do that. Oh, I see. I can divide by 3 over 3. That reduces that down to 5 over 7. 48 over 64. Both divide by 16. We get 3 over 4. 9 over 81. 9 and 9. 1/9. 30 over 45 goes down to 2/3. You're going to need to reduce today. It will make your life easier. If you don't, I'll be nice and help you along. All right? We're going to learn to use informational measures of probability. Experiment, trial, outcome, event, probability, simple event, compound event, complement. Lots to go over today. We have a dice. They're going to call it a numbered cube, because dice is gambling, and oh my gracious, we can't have that in schools. All right. They even rolled it. An activity involving chance, such as rolling a cube, is called an experiment. Each repetition of an observation of an experiment is a trial. Each time I roll it, it's a different trial. Each result is an outcome. Roll it. 5. Oh, 5 is the outcome. Roll it. 4. 4 is the outcome. A set of one or more outcomes is an event. For example, rolling a 5, one outcome, can be an event. Or rolling an even number, more than one outcome, can be an event. All right, now these are our probabilities. 0, impossible. Roll the dice. What's your chance of getting a 7? 0. It's impossible. There's no 7 on the dice. All right, roll the dice. What's your chance of getting a 1, 2, 3, 4, 5, or 6? 100%, because those are all the numbers on there. Even numbers, 50%, and we can kind of figure the others out where they lie. The probability of an event, written P event, that's how we write the probability of an event, is the measure of how likely the event is to occur. A simple event has a single outcome. Rolling the dice, what's your chance of getting a 5? Single outcome. A compound event is 2 or more simple events. Probability is measured between 0 and 1. As shown on the numbered line, you can write probability as a fraction, a decimal, or a percent. Because remember, 1/4 is 25% is 0.25. I'll accept them in any form. I think fractions are the easiest, but some people don't like them. They like decimals. Whatever makes sense to you, whatever floats your boat. Determine whether each event is impossible, unlikely, as likely as not, likely or certain. Rolling an odd number, okay? Is it impossible to do that? Are you certain to do that? Are you likely to do that? Are you unlikely to do that? Or is one as likely as the other? There are 6 possibilities. 1, 3, 5, odd. 2, 4, 6, even. Oh, half of the outcomes are odd, so you're half as likely to do it as not. It's as likely as not that you do that. It's about half a chance of doing that, because there are 6 total chances, and 3 of them meet that. Oh, that's 50%. Determine whether each event is impossible, unlikely, all the way to certain. Rolling a number less than 2, okay? There are 6 possible outcomes. Less than 2. There's only the one that's less than 2. We will come back to this. Weren't there 6 outcomes? With fractions, the bottom number is the total possible outcome. The top is what you desire or want to happen. Oh, there's one thing that meets that? So 1 out of the 6 total choices meets what I want. So we can see that this is unlikely to happen. Okay? Now, rolling a 3 or more. So there's still 6 choices, right? The total possible outcomes. The desired. This one, not so hard. But we have to read carefully. 6 possible outcomes. Hey, the total of 6. Ooh, 3 or more. So these 3 meet, or the desired outcome that I want. So there were 4 out of 6, or 2/3. Oh, that means it's pretty likely that that would happen. Okay, rolling a 3 is likely. Rolling 6 or more on a number cube. Well, there's still 6 choices, 6 total choices, 6 or more. Well, I can roll a 6, that's 6, but there's no other numbers that are more, so only 1 out of the 6 choices meets that. So my desired, what I want, was a 6 or more. Only 1 of those 6 numbers meets that. Total, there's still 6 choices like there's always been. So we look, 1 out of the 6 meet it, 1/6. Ooh, so it's not very likely. Now, when a numbered cube is rolled, either a 5 will be rolled or it will not. Rolling a 5 and not rolling a 5 are examples of complementary events. The complement of an event is the set of all outcomes that are not the event. So, 5 is the event I want. So that means 1, 2, 3, 4, and 6 are the complements. That's the other things that can't happen if a 5 happens. Because it is certain that either an event or its complement will occur, an activity is performed, the sum of the probability is 1. What's the chance we roll a 5? There are 6 different numbers on the dice. One of them is a 5. The complement is that there's still those 6 total numbers, but the complement of not being a 5 is 1, 2, 3, 4, and 6. There's 5 out of 6. When we add a thing and its complement, we get 1. Because that's 6 over 6. Isn't it? All right. So a bag contains circular chips that are the same size and weight. Now they got us dealing with poker chips. Oh my. There are 8 purple, 4 pink, 8 white, and 2 blue chips in the bag. The probability of drawing a pink chip is 2 out of 11. What is the probability of not drawing a pink chip? Well, the probability of drawing a pink chip is 2 out of 11. Well, I know that a fancy way to write 1 is 11 out of 11. So if I can have 2 of those ways be a pink chip, the rest of the ways, 9 out of 11, will not be a pink chip. And the reason or how they get 2 11ths, there are 8, 4, that's 12, 8 more, that's 20, blue, that's 22. There are 22 chips in the bag. How many of them are pink? 4. So I reduce dividing 2 over 2, and that gets me to my 2 11ths for my chance of drawing a pink chip. All right? Let's see what they come up with. So, pink or not pink? They told us pink was 2 out of 11. Not pink is the rest. So 2 11ths plus the not pink is 1. So we subtract 2 11ths from each side to get that pink, or that variable all by itself. Inverse operations. Pink is 9 11ths. Let's do it one more time. A bag contains circular buttons. Oh, now good, we're dealing with clothes. The same size and weight. There are 7 maroon buttons, 3 sky buttons, 5 buttons that are white, and 5 lavender buttons in the bag. The probability of drawing a sky button is 3 out of 20. What is the probability of not drawing one? It will happen. So the other option is for it to not happen, and they have to total 1, so 17 out of 20. All right? So, sky button. There were a total of 20 buttons in there. 3 of them met the desired outcome they wanted. 3 over 20. If I add that to the ones that are not sky, it's going to equal 1. So I subtract 3 out of 20 from both sides. Get this P all by itself. When I do that, the not sky ones are 17 out of 20. Mandy's science teacher almost always introduces a new chapter by conducting an experiment. Mandy's class finishes a chapter on Friday. Should Mandy expect the teacher to conduct an experiment next week? Since the class just finished a chapter, they will begin a new chapter. And it is likely the teacher will conduct an experiment, so yes, yay, an experiment. All right. After completing a unit chapter, Alice's keyboard instructor usually begins the next class with a time trial exercise, practicing the previous skills learned. It is Wednesday and a unit chapter was completed the previous day. Will the class start the trial exercise, the time trial? The teacher keeps to her plan and schedule. It is likely they will do that. Probability is not too bad. They're just having you generalize now, but that total being on the bottom, the total number of choices, and the desired number of choices being on the top, that's the easiest way to do probability in my mind.